Hi everyone, welcome. Thanks for joining me today. And I'm really excited to talk about model monitoring for NLP. Before we dive into the presentation, want to give you a quick overview about me and Verta. My name is Meeta and I am leading product at Verta. In the past, I have built products focused around data annotation, voice AI, and application performance management. And I was an engineer before I decided to dive into product management. I love to work closely with our users and really co create value. And at Verta, we have built a platform for data scientists to help operate and scale machine learning in production. And that includes model versioning and better experiment management, model release management process, we have a model registry feature, model deployment, and finally, production model monitoring. So this is the agenda for today. First of all, we'll talk about why is production model monitoring essential. Second, what is model monitoring and reasons why it is a hard problem if you talk about NLP space. And third, how do you monitor NLP models? The tools and techniques to effectively monitor and perform root cause analysis. And finally, we will wrap up. So why is production monitoring essential? Now, NLP models are everywhere. Customer support, finance, healthcare. If you look at the industries overall, there are myriads of use cases for it, from chatbots, credit assessment, to search recommendations, to even voice assistants. The practical applications and use cases are many. And I was just going through a recent survey about state of the NLP in the enterprise, and it was evident that document classification, NER, and sentiment analysis, they are topping the list of use cases where companies are using NLP for. But again, it's a fast evolving space, and pandemic has fueled further investment. And given the cost savings that NLP brings, it's a space where companies are investing more and more. So NLP models are everywhere and are used in business critical applications. However, the current state of the art to run NLP in production is concerning. Models fail all the time, unexpectedly, and often silently. From examples like biased model predictions to robots making wrong financial recommendations for you, to credit scoring models going crazy after pandemic, they are just some examples just to scratch the surface of the issues that we are facing today. And unfortunately, in many cases, as data scientists, we find out about these failures after user complaints, which is not the ideal state. Let's speak through the reasons why models fail. The first reason is training and test data is frequently different. This is a benchmark done on how widely the distribution shifts between training and test data that ultimately results in low accuracy models. And what they have found out is many consumer applications, models are trained on data collected from one set of users, and then the model is deployed to the universe. And if you look at this on an average, model performance could be satisfactory, right? So overall, the accuracy score is looking fine, it's 80% or 85%, and it's acceptable. But if you look into the finer details, it can perform really bad for a specific subset of users, which are sometimes overlooked. And then the other reason is the underlying data or the process to generate data can change unpredictably. The prime example is the credit scoring systems failed during pandemic because suddenly consumer behavior shifted. And there are similar examples even in healthcare domain. We are talking to one of the experts in healthcare, and he shared a similar concern. And this is another quote about the healthcare lab result scanning, where the model is exposed to a new lab every time the model is rolled out to a new lab, or a new diagnostics, different data format. Either new features popped up or the distribution of existing features shift considerably. So every time you need to be on top of your effort to avoid these kind of failures. And then, of course, models are rolled out to new markets, new users, and edge cases pop up all the time. And one example, use of voice assistants in classrooms, that is growing. But the speech recognition systems are not ready to work effectively for kids. So data drifts, concept drifts are expected and have significant downstream impact on model performance. And then, similar to software, bugs and errors either in the model, the ETL pipeline, or code can lead to model failures. You release a new model version and that introduced an unexpected bug. And this is pretty common. But the thing is, we need to catch those bugs and fix it. That's where our focus should be. NLP is a hard problem. They involve complex linguistics, there is ambiguity, context, emotions, and all the nuances of human language. So it's a learning process. As we launch NLP models, they're exposed to more users, and we need that to learn and adapt, but not at the expense of silent failures in production, and we have no clue we released a model and it's failing. So just to bring it home, AI ML doesn't always work as expected. Nonetheless, critical business apps are reliant on them. So what do we do? The answer is simple. We need to begin with monitoring our production models. So what is model monitoring? Monitoring ensures model results are consistently of high quality. And it involves three key steps. First, knowing when models fail. Second, if a model fails, you are able to debug and quickly pinpoint the root cause. And third, you have the automation in place for a faster recovery or resolution. And these are like all super critical in order to effectively monitor your production models. From concept drifts to model performance, user segmentation and cohort analysis, alerts, outliers, data drift bias, and we'll touch upon most of these areas throughout the presentation. Now, creating an effective monitoring solution for NLP is a hard problem. So let's discuss why. The number one reason, knowing when a model fails is not easy. Now, how would you know when a model underperforms? One option is to compare model output with ground truth and evaluate accuracy or similar quality metrics. It could be F1 score, it could be something else in your use case. However, unlike regular software, quality feedback is not instantaneous for ML. So you may have to look at other indicators like maybe output distribution and compare training and test set, or input distribution, as well as intermediate data points. This is one layer of complexity that you will deal with. Number two reason, if you think about NLP models, one size doesn't fit all. The reason being, you may use different frameworks from PyTorch and Keras to Mbert and so on. Your models could be running in batch mode, live mode, both, and you need visibility to data pipeline. The model serving infrastructure is another variable in the mix. You may be running Java objects, maybe in serving the inference in-house, maybe using another vendor platform. And then metrics and visualizations, they need also to be addressed. And the needs change considerably with each model. And as you expand the model, you may have different requirements. Maybe you need n-grams, embeddings, word length calculated. So again, the type of metrics and the way you want to visualize them also evolves and changes with each model and as the model matures. The third reason, finding the root cause with a complex machine learning pipeline. And we have seen this over and over again, that ML data pipelines are usually very convoluted. It's called a pipeline jungle. If one step in the process breaks, all the models consuming those pipelines can get impacted. But the root cause analysis is extremely hard since we lack this sort of complete picture, what is connected to what, where things are failing, and how is that impacting downstream. And this is a challenge everywhere. And number four reason is many models are black box to us. It's great that we have all sort of off-the-shelf models, tools like AutoML that helps non-experts consume the models. However, it comes with its own challenges during production monitoring. And this is a quote from a data science lead we were talking to. Engineers with minimal ML expertise consume these models, and so they are black box to them. We try our best to tell the product team when something is wrong with the model, but that's really hard to do because we don't have all the insights about the intricacies and the details of a model. And number 5 reason is the existing monitoring systems do not work for data science. And I'm going to specifically talk about APM tools, application performance management, and that's a space that I was pretty familiar with. And most teams naturally gravitate towards APM tools when things go to production. So we've spoken to so many teams where they're using APM tools to monitor ML in production, and that's not really working for them. And you may be familiar with some of these tools like Neuralink, Datadog, or App Dynamics. Great tools, but they're not geared towards data science or NLP. And APM tools really offer informations like health, response time. They generate alerts. Let's say if response time of your inference service dips, the tool will alert you. But the question is that sufficient for NLP models and data science teams? Unfortunately not. You need access to a variety of statistics from histograms, distributions, drifts. You need custom data visualizations like confusion metrics or word embeddings as examples, and then get alerted on meaningful deviations. And current APM tools are really not built for data science. They're really built for software. For data science and for NLP, you need a completely different set of toolkits. So, how do you monitor production NLP models? First of all, know when models fail. That's a step 1. Step 2 is drill down and analyze the root cause. Step 3, debug. Step 4, remediate. And every step needs a well thought out tooling to be in place. And we'll talk about that next. Now let's look at one example. Let's say you have built a sentiment analysis model, and that uses IMDb movie review datasets. I'm sure most of you are familiar with IMDb datasets, and there are a lot of examples out there. And this is essentially a classification model. So how would production monitoring look like in this case? Now the first step is to have visibility when models fail, right? Now, how do you measure model quality? You use ground truth. How do you get ground truth? Maybe hand leveling, which is definitely an option. Maybe additionally, you can rely on system signals, like if someone upvoted the review, or proxies like user complaints. So there are different ways to obtain some kind of feedback that helps you calculate quality. So you have access to ground truth, and the ground truth is ingested to your monitoring system that calculates quality metrics. It could be accuracy, F1 score, mean square error, or anything that is relevant to you. And this will ensure that you have a time series view of your quality metrics. Like you may have a view of all your accuracy data over time. And you keep tab of historical trends and ensure that the accuracy is not dropping below a certain threshold. And you can configure an acceptable threshold and get alerted if, say, your accuracy falls below a certain value. Like in this case, if it falls below 0.85, I would like to be alerted. So actually now you can keep tab of your accuracy, which is a good indicator of your model performance. Another thing to keep in mind here is how is the model performing across different user segments. And we covered that in the middle of the presentation, where we spoke about overall the model may be performing well, but it may not perform well for specific subset of users. So the segmenting your users is really great to look at that view, right? So having a view of overall accuracy is great, but let's say you suddenly expanded the model to a new geography or a new user group. You need to track closely if the model is performing well across the board, and you can segment your user groups and look at accuracy for different geographies. Like how is my model performing in US versus in Australia, or how is my model performing for different age groups or different genders. And I have set my accuracy threshold to be 0.85 again, and I see alerts for a bunch of geographies. So maybe my model is doing well for one geography but not in others. So then I can have a quick look at the reason behind it. And tracking performance over model release is also critical. So it's not a good sign if the accuracy drop after a new release. And typically you would expect to see a bump in model accuracy with each new release. If that's not the case, at least still the accuracy should not drop, right? The other things that you should consider are tracking different language models, or how models are performing for different device types, or even user demographics like age, gender. So again, having a view of having a way to segment your users and looking at the metrics from that lens is also useful for production problems debugging, as well as just to give an idea of model performance for different user groups. Now, since my accuracy has dropped in this particular case, I need to drill down further. Confusion metrics can help drill down the issue into finer details. And you can compare confusion metric snapshots of training versus production. And as you can see here, it's obvious that there is a lot of false negatives for a negative sentiment classification, which could warrant more closer look. And again, I'm giving one example of confusion metrics. Like this is how you can debug a problem, but it could be any other the charts and graphs. The catch here is you need to have full control to create different custom visualization, which is relevant for your use case, instead of getting trapped on a line chart or one particular metric, right? So this is just to showcase that what type of complexities and customizations you need to monitor your NLP models. So what if you cannot calculate model quality so easily, right? So in the previous case, you had access to ground truth, you could calculate accuracy, and so you can drill down further, look at the confusion metrics, which is all great. But do you always have access to this quality metrics, right? The reason being, you don't have access to ground truth all the time. And what we have seen is this is very common in production scenarios. Folks do not have access to ground truth. They do not have the process in place. Or it could be a scenario where you do not get feedback on all predictions. It could be really costly. So maybe you have access to a subset of predictions where you can obtain ground truth. Or even the feedback is not instantaneous, right? If you're relying on hand labeling to generate ground truth, that can take anywhere between a couple of weeks to months. And your production systems cannot wait. So if there is a failure, you need to fix it. Also, another layer of complexity here is feedback is not always black and white. If I classify a review as negative, that may not necessarily mean that you would feel the same way, right? So there is always that those nuances because NLP always deals with humans, right? So how do you avoid or remedy model failures given in the absence of ground truth? You look at the other indicators that impact model performance, and that includes output distribution, input distribution, and drift between training and production, or other intermediate data points. So basically you are looking at the data distribution and data quality versus just quality metrics. So again, there are different ways that you can compare your input training and test set. You're looking over a time series view of your input data and seeing if there is any major shifts. Now for a sentiment analysis model, you start with tracking prediction count. So we're looking at output distribution since we do not have access to quality metrics. Let's look at output distribution, right? So we are tracking output predictions over time. And this is a prediction count for different classes. So now the output of the model is a positive class, a negative sentiment class, and a neutral. The distribution should be pretty consistent over time. And any spike can indicate issues with the model. Unless it's an expected spike, we should see a very similar distribution. So for example, suddenly my model starts classifying reviews as negative, and the count for neutral sentiments classification that goes down. I would assume something fishy is going on, and I may have to drill down. And for this particular scenario, I have alerts set up, right? If there is a sudden spike in a classification, in certain class, then I need to be alerted and I need to take action. Now, having a histogram view of the distribution will also help. You get a clear picture. This is a discrete histogram to look at normalized distribution of different prediction classes. And in this case, I'm looking at how the distribution looks like across different classes. And we have a new release that happened sometime in the near past. And the other question is that a reason for a sudden change, or maybe not? But at least it's a valid data point that can help me get started. Now, model input is another indicator to help figure out underlying shifts in data. So we looked at output distribution. Now let's get a view of input data. How is my input data looking? While tracking down the distribution of input data, we realized that some columns like movie genres are showing a big shift in the distribution. So this is my training versus this is my production. So there is something wrong between training and production. So maybe my model is not trained on specific data sets or specific areas, and that's why I'm seeing some issues in production. Maybe that's the case, but at least it's again looking at the input data, I'm seeing some variabilities or drift. How do you perform root cause analysis in this case? So we are kind of zeroing on few of the areas, but let's figure out what would be the ideal steps to do a root cause analysis. Now, for different NLP use case, you may need different ways to track and visualize metrics when it comes to root cause analysis. One most common way is to look at n-grams. And typically you'd look at 1 gram or the bigram. That's the max that I've seen our users looking at. And you can track the top 50 or 100 n-grams for different prediction classes and their corresponding frequencies to get a picture of your production data. So for positive sentiment class, I'm seeing these are my top 50 or 100 n-grams. And for negative sentiment, these are my top n-grams. And then you compare training versus production to see if there are any changes, right? So these are my n-grams for training versus production, and I see a big change there. And this will give you an indication if there a training set is not a good representation of your production. And next you can compare n-grams over time. So there is a comparison of n-grams at a particular snapshot and comparing with training, and then also looking at the distribution over time is also useful. So in this case, we'll switch to a different view to track shifts in the ranks of n-grams over time. And bump chart works great for this purpose, and a lot of our users prefer that. This lets you track if ranks of specific n-grams have changed significantly. So essentially you're looking at the biggest movers, they are of interest, right? So new entrants, if something has dropped from the top 100 list, is a point of interest for you. And for the earlier scenario where we saw a spike in false negatives for negative sentiment class, you may see an increase in certain n-grams in the negative category, which may otherwise would be under neutral. So that is an indication that we are categorizing some of the n-grams are not categorized correctly, or we need some kind of model retraining process. And as we zero in on the problem area, which seems to be a misclassification due to a gap between training and production, you need to get into the weeds, and which includes certain debugging steps. At Inverta, what we believe is monitoring helps you know if a model is underperforming and doing root cause analysis, and you may switch to a debugging tool of choice if you want to drill down further. And one example could be a token analyzer, and you pick specific data samples like one particular movie review and look at the tokens, whether positively or negatively impacting the prediction. You apply certain changes and evaluate the impact. So you kind of play around with using a token analyzer to figure out whether the issue that you've analyzed is actually correct and you need to take some actions. And another debugging technique is word embeddings, which is also widely used. You capture word embeddings between training and production and compare that across different sentiment classes. or between specific instances of production, like timestamp A versus timestamp B, and see if there are any shifts or changes. So again, another really useful tool for NLP models, which could help in debugging your production problems. Now the final step is remediation. Looking at this shift in distribution or monitoring your data pipeline can help you identify upstream data issues sooner, and you may prevent a production failure. Or if you see some major issues, you can fall back to a prior release. Go a step further and automate the retraining workflow. So in case we notice that training and production data are widely different, which is the reason we are seeing a spike in negative sentiments in the earlier example, you may just have to start a retraining workflow, and that will fix the issue. So the level of automation that you can introduce in the process can help you react to these problems much quickly and solve production problems. But the first step in the process is to really know when the model is failing and finding the root cause. And but then remediation and automation is also a key step, so that your customers do not continue to get a degraded experience, or if it is a problem where you're losing revenue, that's also something to worry about. So let me give you a quick peek on Verta's approach to model monitoring. Our view of the world is this. A good model monitoring solution should do the following. It should tell you when models are failing. It should be customizable. So you bring your own statistics, you can define your custom visualization, and build your own charts and graphs. And as you can see in the earlier examples, there are so many different tools and techniques that you need to monitor NLP models, and that list is even bigger. So having those customization options is really critical. And the monitoring solutions should be data science friendly and not just DevOps friendly, right? It should give you a complete picture of the model and data pipeline to help you identify root cause faster. And finally, it should help you close the loop. So in a nutshell, a good monitoring solution should help with monitoring, automation, and incident response. So how does it work? And this gives you a high-level picture of our overall architecture. You start with data ingestion. So that means you are ingesting your input data and output data of your production models. It could be either a batch model or a live model, or if you're monitoring your ETL data quality, you can also ingest your ETL pipeline data. And if you have access to ground truth, ingest ground truth as well. And this essentially goes to a time series database and generates various statistics based on the data type, either through, there are out-of-box functions, which we call profilers. These profilers will generate those charts and graphs for you, or you can build your own custom profilers. And finally, you can visualize the statistics in a web UI, or you can get notified about unexpected events. Like you can get notified with the tools of your choice. It could be PagerDuty, it could be a Slack notification, it could be ServiceNow. So essentially, you don't have to change those workflows. And finally, you take automated actions for remediation, which could be starting a retraining workflow that we previously discussed, or if you have a bad release, you can roll back, or you need human in the loop for labeling it. Those things could also be automated through webhooks. And we have like configuring profilers and alerts, a function where instead of using out-of-box profilers or alerters, you can build your own alert mechanism and just codify that programmatically. So again, the goal is provide out-of-box functions, but give you the enough flexibility to customize it. So hopefully by now, I have convinced you how prevalent our NLP applications are, and given the nature of business criticality, we need to ensure models are delivering high quality predictions. Now, given the nature of NLP models and how unique each use case is, we need fairly customizable tools and processes to help detect if a model is degrading, quickly do a root cause analysis, and drill down to debug, and finally remediate it faster. And if you ensure you have 360-degree visibility for your model, you can identify failing models before social media does. safely democratize AI, and roll out the controls to more teams. More teams can launch models, but at least you have controls in place if they fail. But more importantly, quickly react to market changes, which happens all the time. So, which is again super important. And I really want to thank you for joining me today. If you want to learn more about Verta's approach to model monitoring, please visit this URL monitoring.verta.ai and find out more. Also, do sign up for our monitoring community preview program. We have rolled out this program and it's designed for ML practitioners to closely collaborate with us and integrate monitoring into their production workflows. And you'll get access to this feature for free. Please let me know if you have any questions. Thank you.